one, it's going to be a little bit more useful because we don't have that h floating around in there.
Right.
Can I help you?
This is Mrs. Camp.
Okay. Okay, so let's see if we can apply this one instead. And remember, we're looking for f prime of x, but what we can do when we're done, if we apply this definition here, is we can just change the a into an x at the end, because that's really what we want, and just use it that way instead. So back up so we can see both here. All right, so instead, let's go this route. So we'll do, like I said, f prime of a and then f of x is the square root of x. F of a would be the square root of a over x minus a. Now some of you guys might look at that and go, okay, Mr. Herrick, that's not much better than the last one. There's still really nothing that we can do there. But in this case, there is, and we have to get a little bit tricksy here with it, but we can do it. So first of all, does everyone see how I'm essentially multiplying this whole thing by 1? Right? And by multiplying by 1, I'm not changing the value of it, so it's okay to do. Right? Okay. Now, the question becomes, how in the world did I come up with this, though? Square root of x plus square root of a, square root of x plus square root of a. It's all based on this over here. Okay? We have it square root of x minus square root of a, and over here now a square root of x plus square root of a. If you multiply these two things together, and they are conjugates, one's a minus, one's a plus, other than that they're the same. When you multiply conjugates together, things cancel out kind of nicely for you. So take a look at what happens next here. So we have the limit as x goes to a. On the top, square root of x times the square root of x would be just x. And then you're going to have negative square root of a times square root of x, so minus square root of ax, and then you're going to have square root of x times square root of a, so plus square root of ax, and then square root of a times square root of a minus just a. And then on the bottom, x minus a square root x plus square root a. I'm not going to multiply those together just yet, and I'll show you why here in the next step. Okay, but everybody with me so far? Just distributing the top, not distributing the bottom yet. And canceling stuff out up there, I'm just going to have x minus a left over. And then on the bottom, x minus a square root x plus square root of a. What do you now notice? You've got a factor that cancels, and in fact, it's that x minus a factor, which is the one we kind of sort of wanted to get rid of, right? So that we can actually try substituting that a in there. So with both of those gone, got the limit as x goes to a of 1 over square root x plus square root a. And so if I take this a and plug it in now, because I can, I have 1 over 2 square root a, because it would be square root a plus square root a underneath there then. Okay, so if this is f prime of a, right, work through all of that to get there, then what is f prime of x? It's not supposed to be a trick question. If f prime of a is this, what's f prime of x? Same thing, but the a is now a x, right? Yeah. So f prime of x equals 1 over 2 square root x. Got it. Okay? And we were able to go through that alternate definition to get there. Okay, using this a as kind of our little placeholder for x. So this right here, this definition, this is an important alternate one. Sometimes when you're calculating a derivative, trying to use with the as h goes to 0 way, you run into a roadblock, and then maybe you pull this one out instead and try it, and yeah, see how it goes.
How did you get 1 over 2 square root of a?
Because if I plug an a in for x down there, because I can, it's not going to make me divide by 0 now, I'd have the square root of a plus the square root of a, which is 2 square root of a. So, doing like the calculation stuff of derivatives, you guys are going to have some practice with that in your homework, and that's all well and good. The other thing that I'd like to talk about with you guys is this relationship graphically between a function and its derivative. So we're going to look at how do you graph f prime from f. And this is going to be kind of an inexact science. It's going to be a little bit of guesstimating and stuff like that to kind of get an idea of what the shape would be. So, you know, there are going to be some answers that might, like, you know, one person sitting next to another person might not have a graph that looks like exactly the same, but we're looking for some key features from one or the other. So, all right. So let's start with a graph here of f. All right, and we'll put some scale on this thing here. We're going to point out some key points here. So this particular point is going to be at 6. This one up here is going to be at 2. And then at 3, be right there. And this one, I'm just going to tell you, the slope is equal to -1 at that spot. And then at 5, same thing, they'll have the slope equals -1. And then at 1, that'll be the slope is equal to +1. Okay? Okay. And the y value, because an instantaneous rate of change is measuring what about a function? Its slope, right? So if we're trying to figure out f prime from a graph of f, do I care one bit about what the y values are? No. All I care about is what's the slope, what's the slope, what's the slope, what's the slope, bless you, from each one of those points as we go through it, okay? So just keep that in mind. I'm checking out slopes as I go, and then I'm going to use that to make f prime, okay? So I'm going to come over here and make a little chart. You don't have to do this every time, but I think this might be helpful as we kind of look at this originally. Actually, you know what? I don't even need that last column because I don't care what f is. I just want f prime. Okay, so for each one of these, I've got some x values that are some points at some specific x values of interest here. So we did when x was equal to 1, 2, 3, 5, and 6. Okay, f prime is the derivative. The derivative is the instantaneous rate of change. The instantaneous rate of change is the slope. The derivative is the slope. Okay, you're measuring slope. So f prime, I'm just recording slopes for all those points. Okay, so this one we said we had a slope of 1. So f prime at 1 is 1. At 2, think about tangent lines again. Here's at 2. The slope of that line is 0, right? So 0. At 3, what's f prime? Negative 1. At 5, what's f prime? Negative 1. And at 6, what is f prime? 0. Okay, so we've got, think about, slopes of little tangent lines at each one of those places. Okay, now in this particular picture, I gave you some slopes here of these points. In practice, you're not always going to have that to work with, so you might have to just kind of eyeball it and say, okay, then I guess it kind of looks like it might be 1 or 2 or something like that. Slopes are really hard to judge. I mean, as soon as you get a slope bigger than 1, I mean, how do you tell the difference between a slope of 2 versus a slope of 3 just by eyeballing it? It's kind of difficult. So that's why I said you might have some things where it doesn't exactly kind of work out. But important things to note, which we'll do in the next one, is where are the slopes positive, where are the slopes negative, and where are the slopes 0? Those are going to be your key places you're going to be interested in. And we'll dig in a little bit more on that in just a second. But in any event, since we have this stuff here, we can start making a graph of f prime now. And I'm going to need positives and negatives, so I'm going to draw it like that. And let's say 1 is up here, negative 1 is down there, just to give ourselves a little bit of space here. All right, so when x is 1, f prime is 1. When x is 2, f prime is 0. When x is 3, f prime is negative 1. And then at 5, also negative 1. And then at 6, it's 0. All right, so do you guys kind of see the shape of this thing starting to come around here? What's it going to be in the shape of, do you suppose? Based on how those dots are on there. What kind of graph would fit that real nice? Parabola. Okay, so a sine wave maybe, yeah, okay. But no, it's a parabola though. So it kind of does one of these. Okay. So, and we'll talk more about this in the future, but if we're talking just strictly polynomials here, what kind of polynomial does it look like we had at the beginning with f? What degree does that look like it is? Cubic, right? Third degree? Looks like a cubic. What do you notice about this one? What happened to that degree? Drop down 1, right? Now it's a degree 2. It's quadratic. Okay? That is not a coincidence. That happens when you do derivatives. So, all right. So here's f of x. Here is f prime of x. The graph of that derivative function that we started with up there. Yeah. The degree of a polynomial is x to the third is a third degree. X squared is a degree of 2. So, okay. Now, like I said, there's a key connection between these as far as when the slopes are positive, negative, and 0. Okay? So, in this original function, give me one interval where the slopes are all positive. From 0 to 2. What do you notice about the derivative from 0 to 2? Is it?